Okay, hello. In this video, we're going to introduce run the algorithm. So this is something we want to be able to do, and we'll look at 3 different examples. I am going to have you pause periodically because we're going to go through this reasonably quickly. Okay, so first of all, we're going to look at linear search. We have a list of numbers. We have some number that we're looking for, and we want to find, is that number in the list, and if it is, what is the index? So we're thinking of this numbers could be a Python list, and then the index is just 0, 1, 2, 3 up to whatever. Okay, so the goal is find that number 4. Okay, all right, so the basic idea for linear search is we're going to look at one number at a time. So right now, if I put my current index at 0, I'm checking 5. Is that equal to 4? No. Then I'm going to go up with my current index. At index 1, it's actually the value 1 there. That is not equal to 4. So remember, I'm looking at just checking each one of these to see, is it equal to 4, yes or no? So this current index will keep going up, and it will end up getting up to the value 7. And as it goes up, when it's 3, I'll be looking at this number. When it's 4, I'll be looking at this number. When it's 8, I'll be looking here. When it's 3, I'll be looking here. And when it's 10, I'll be looking here. Okay, I get all the way through the end. I didn't find 4, so I would conclude that it's not in the list. Okay, so one note about this algorithm, the list of numbers doesn't change. Okay, so we're just running through, keeping track of information. All right, that's it for linear search. There's not really much going on here. We just kind of, this is very similar to play the computer. There's not much different than play the computer. Okay, so we're going to move to binary search. So if you want to wait to think about this for a second, pause now. All right, binary search, we have the same list of numbers, but they're sorted. So with linear search, the list of numbers does not need to be sorted. We could always run this algorithm which just checks everything. Okay, so binary search, if the list of numbers is already sorted, we can be smarter. Okay, let's say that we're looking for the number 4. Then a reasonable thing to do would be to look in the middle. And one of these, 3 or 5, let's just say that this is the middle. Okay, so the way binary search is going to work is you look in the middle, and if these are in sorted order, and I'm looking for 4, and I see that there's a 3, then I know that none of these, none of these do I have to worry about, because 4 is bigger than 3. So I would be looking on this side. All right, and the way that this works, more towards the code, is at any given time we have a low index that we're possibly looking at and a high index that we're possibly looking at. So at the moment, before we do anything, we're looking right here, and then we go to the middle of that range, and that middle of that range, let's just say it's 3. So I'll highlight 3. Okay, so in index 3, just happens to be the same number there. All right, I see that 4 is smaller, so then I know that I don't have to look at any of this, because 4 is bigger than 3. It has to be over here if it's somewhere. So I don't know what these numbers are yet. I just looked at that. So now my low index is going to be 4, and my high index is going to stay 7. So these are the ones that I'm looking between now. And it's either going to be the index 5 or index 6. Let's say that it's index 5. Okay, so I look there and I see a 6. And if 4 is going to be in my list, it can't be over here because all of these are bigger than 6. Okay, so now what I'm left with is just index 4. So I look there at just index 4 and it's a 5. And it's not the number I'm looking for, so again I conclude that 4 is not in the list. The interesting thing to note here is how much work did I have to do? How many different numbers did I actually have to look at? I highlighted them as I looked at them. So I looked at this one, and then this one, and then this one. So I only looked at 3. We only had to look at 3 of the numbers in the lists. That's good because that's better than linear search. Linear search, we had to look at all of them. This only works if the numbers are sorted, and again, the list of numbers didn't change. Okay, so this is very similar to just playing computer. Now for the next one, things are going to change and we're going to keep track of them a little bit differently. Okay, so at this point, we have 2 algorithms, 2 ways to search for a number. With linear search, you just check them all, but then you potentially have to look through every single one. Binary search works if they're already in sorted order, and it seems to be much faster. Okay, now for sorting, we actually want to change the list of numbers. So I have that list of numbers. What I would like it to be in the end, just looking at it here, there's not too many numbers there, so we can just kind of look through it. It's going to be this in the end. Okay, so that's the goal. Now the list of numbers is going to change. Okay, so this is where we have a new kind of thing. So I'll put the numbers here, and I'm going to put it into stages. So stage 0, I'm going to call it, is just the way it started. Okay, and then I'm going to copy that and show what it is after stage 1. Okay, and the basic idea for selection sort is one of the ways that you would think to sort numbers. When I'm up here, find the smallest. Okay, so I'll highlight that. So there's the smallest. That one should be in the front. Okay, there's different ways you could put it in the front, but what I'm going to do is just switch it. So switch it with that one. Now the 0 goes in the front, and the 5 goes there. Okay, so that's the way selection sort works. So we find the smallest and switch it to be in the front. So then I'm going to do the same kind of thing again. This was my numbers. Now I know that I'm going to put this as bold because I know that that's the smallest. I already did that. And now I want to find the smallest of whatever's left. And it just happens to already be in the right place. So I would switch that with itself, but it doesn't really need to be switched because it's already okay. So actually nothing really changes there at that stage. Okay, so now the next stage, I need to find the next smallest. I already know that these 2 are the smallest. The next one is going to be this one, and it really should go here. So we're going to switch those. So for stage 4, we'll put that 2 in position. And we know that those are the smallest now, the ones that are in bold. All right, so at this point, you want to pause and finish this yourself and show what it looks like at each stage. Okay. I think it was actually off here by one. This is really... Okay, so this was the one where nothing happened. We moved the 1 into position, and now we moved the 2. So there was the one time where nothing changed. All right, so but for the next stage, we have a 3 is the next. This should have been, so this really should have been that we were looking on that one, depending on how we're keeping track of things. Right. So I'll just say that this 3 then really needs to go into that position. Okay, and that's what's going to happen on the next stage. That'll show up. Okay, the next time we already have these in position, and that one's already there. So we would have looked here, and the smallest that's left is already in the right spot. Next up, we would see that the 6 is the smallest, and that's going to get switched here. Okay. Next up, we would be switching, we'd be looking for the smallest of what's left. There's an 8. It's already in the spot it needs to be. That would be it. And then we only have one item left after that, so that would be the end. Okay, so what we've done here is, so we ran the algorithm, selection sort, and kept track of what the list, what the data structure looks like at each stage. So I didn't look at every single variable that would be in a program to do this. I'm just looking at kind of the high level idea. And the high level idea right here is you're finding the smallest and put it first. That's what's happening here. So and the high level idea on this one is find next smallest, find next smallest, and so on. Okay, so each time here, this is really, like this part right here, this is really a loop. To do this whole thing is really a loop. But to show how the algorithm changes the list, I'm just showing what the list looks like each stage. So I'm calling one stage is going one time through and finding the smallest. Okay, so this is run the algorithm. Excitement.